Hi, I wanted to share something I've been working on for the past couple of weeks. If you ever worked with US healthcare provider data, you probably started with NPEPES. It has over 9 million providers. It's free, it's open source, it's public, but it doesn't tell the whole picture when it comes to specialty for the provider. If you want that information, you kind of have to combine other CMS data sources. I've worked on combining 11 other CMS data sources and try to fill in the picture of a provider's specialty, their MIPS scores, their utilization, their affiliations, if they are excluded uh, by CMS. And I would like to share that with you. So if you show you over here, I've built all this into a medallion architecture where I get all of the raw data into my bronze layer. I clean it up, I typecast it, remove any nulls and other standardizations in my silver layer. I compute the specialty in my intermediate layer, and then I have a gold layer which is used to serve my API and my dashboard that we're looking at. There's also some seed data that comes from NUCC and CMS sources that are used in this product. Everything is built using DBT transformations, so it's documented and tested. The next I want to show you is the main challenge, which is the algorithm that helps us determine the specialty resolution. So if I was to take one of these examples, since there are multiple sources and NPs is essentially self-reported, it cannot be fully trusted. So we integrate with other sources to see more signals and gain more confidence in the specialty that the provider practices with. So in this case, for Dr. Rashid Khalil, there's an NP's reporting of anesthesiology, and the Medicare crosswalk does agree with that, and as does the PDC enrollment when they enrolled for Medicare. And they don't have any claims data in this case, so we don't go based on that. But 3 out of 4 sources are suggesting a high confidence for them to be in anesthesiology. If you look at another example where claims are available, right? Let's look at this one. Here we can see that the claims override the specialty, right? They are self-reported as a surgeon, and the Medicare crosswalk agrees with that. Their enrollment is in cardiac surgery, but more specifically, they have all of their claims data pointing towards a more specific specialty. So that's what we kind of go with. This is an example of a PDC override where we have cardiovascular disease as the focus, and that's what becomes our specialty. I also would like to show you this provider detail page. So I'm going to go into search and search for the same provider we were just looking at. So this is our provider detail page, which also shows us where all of the data comes from, right? In this case, if we hover over, we can see NPs is the source for this data. Whereas if we go into specialty, we can see that we're getting data from PDC, it's color coded. We're getting some from MIPS, which is orange, and some more from PDC. All of the data is not just telling you the specialty or the value of the field, but it also tells you about where it came from. So in this case, the name, it came from NPs. right? Let's look at some more examples in this JSON. So the resolved specialty, in this case, cardiovascular disease, came through a PDC override. The confidence score is there, and then it even tells you all the signals of where the data came from. Address came from NPs. Graduation year came from PDC. MIPS scores came from the MIPS dataset. So you get the idea. They've not been excluded. That came from the leaf file. So you get the idea, right? Now, if I talk about the tech stack, we are building this using BigQuery in production on Google Cloud. It has a Python fast API that queries this dataset. We have a Next.js React front end that calls the fast API. And all of DBT transformations are done using SQL, and we use infrastructure as code with Terraform to deploy the infrastructure on GCP. And for local development, we're using DuckDB, which allows us to iterate quickly, test things locally using DuckDB. And we have a bunch of mock data that has been set up, which mimics the production data, but it's a much smaller data set. We use Cynthia to generate that mock data. And then we have some additional scripts that generates CMS-like mock data. And then I'd like to show you, yeah, I think that pretty much is all I wanted to cover. So mostly if you're building anything in healthcare that touches provider identity, anything to do with specialty verifications or Medicare enrollment status, exclusion screening, this is the kind of foundation that you would want from a data platform that allows you to work in this problem space. And I wanted to kind of learn and build something that would be useful for anyone who's looking for those kind of solutions. So thank you for watching.